Presentation is called Is Correctness All You Need? So the purpose of this is to audit LLM evaluation bias with the help-steer dataset. This was found on Hugging Face. My name is Ethan Norton and I'm part of the Northwestern University MSDS program. And the context of this paper is with CMU Masters of Science in Machine Learning, which is the program I'm looking to apply for. It's based on reproducibility and bias awareness evaluation. The problem statement for this project is LLMs are increasingly used in high-stake contexts, but rely on biased, unstable human value annotations, especially in the context of this problem. So I found that correctness is overemphasized, which is approximately 70% of high scores. It's either rated at 3 or a 4 on a scale of 0 to 4, but it overshadows the complexity and coherence. So with this being said, my research question is, given an answer scored a certain level of correctness, so that's split into 3 or 4 or 1 or 2, how much do annotated complexity and verbosity deviate when engineered metrics are held constant? So for background, I did a literature base. I pulled from the help-steer dataset as mentioned earlier, and it has the annotated features helpfulness, correctness, coherence, complexity, and verbosity. And there's bias in evaluation because there's a mismatch among approximately 200 annotators. And especially for the CMU relevance, it builds on someone I'm looking to work with, Dr. Shaw, and it's grounded in scientific AI review papers. So for the data and features, again, it's the help-steer data set with the attributes helpfulness, correctness, coherence, complexity, and verbosity. And I also engineered additional features using natural language processing, which is word and sentence length variance, lexical diversity type token ratio. So this is different types of verb to other word ratios, and readability indexes, which goes into complexity of words being used, and then repetition ratio and connectiveness, which goes into if certain words are repeated multiple times in the same prompt. So for this research design, I had a framework. Number 1, I performed exploratory data analysis, so I did some visualizations. Number 2, I did the annotated only model. 3, the engineered only model. And 4, a hybrid annotated and engineered model. And I found a key metric. There was a 0.68 correlation between correctness and the total score, which means correctness was the most prevalent variable just with that only factor. For my analysis and interpretations, I found that correctness correlates most strongly but lacks discriminative power. So what that means is correctness correlated most strongly with the overall score of all the variables, but it's not the sole predictor. Next, I found that annotators overrate verbose responses and underrate concise and complex ones. So on average, ones that are scored higher correctness tend to score higher on verbosity and complex, but ones that are incorrect tend to score worse on verbosity and conciseness. I found a hybrid model stabilize R squared and reduce variance across folds. So what the interpretation of this is, correctness is necessary but insufficient only by itself. So reliability increases when human scores are contextualized with linguistic structure and complexity measures. So there's some results that I found. Metric observation implication is correctness had a total R squared, so it was overweighted in the context of the problem. So correctness being overweighted was about the 3 or the 4 scores took up 70% of the sample, and there's weak differentiation. There's verbosity bias, annotators reward length, and subjectivity risk. And the observation or my recommendation is to have a hybrid model. Stability that incorporates stability, because what I proposed is if you have an algorithm and you reassign it based on the complexity and verbosity scores to someone who rates it more higher, there would perhaps be a more accurate correctness representation because they would have more context awareness. So it drives inconsistency, and with this being said, there needs to be some domain-aware annotation. My recommendations are norm dynamic modeling, so model bias evolution and annotation communities. So whether it be an algorithm or whether it be the human annotator, I'm recommending it to be reshuffled based on the scoring first primarily of the complexity and verbosity, then secondary could be judged the correctness. So in terms of Carnegie Mellon University, they have Institute of Complex Social Dynamics. So I'm thinking in the context of that problem, a framework like this could also be implemented. And thirdly, to have automated scoring pipelines, so engineering futures for bias detection, which is something I'm going to explore more in the future. And to formalize the bias theoretically and quantify the process further. So with that being said, is go down into maybe an annotator level basis, or seeing certain annotators that are more capable of handling more complex prompts for correct scoring, and to drive a policy from this going forward in the future. So the executive summary is some key takeaways. Number one is correctness anchors evaluation but fails to capture depth or coherence. Hybrid evaluation is human and engineered in general, enhances reliability. And this framework supports the Carnegie Mellon Masters of Science in Machine Learning themes of model interpretability, fairness, and reproducible ML evaluations. My personal reflection, so what I learned from this project, is this project strengthened my foundation in bias modeling and interpretability. This motivates collaboration, and I wrote my statement of purpose around CMU's Institute for Complex Social Dynamics. And my future goal is to work at CMU or another university to build reproducible LM audit pipelines linking social bias theory to ML architecture design. So some selected works that I use in my literature review were Jing et al. It's from the Help Steer Multiple Attribute Human Annotations, Sean et al. Expertise Evaluations and Peer Review, and Goldberg et al., which Shaw was also a part of, was Peer Reviews of Peer Reviews, which is some framework that I'm suggesting in this paper. And another more general paper is Training Helpful and Harmful Assistance with RLHF. Thank you for viewing this presentation. My name is Ethan Norton. You can reach out to me on my email, my LinkedIn. And so my closing note that I'll leave you guys with is fairness begins with measurement, and consistency isn't necessarily an indication of fairness, but correct representation is what can lead to better audit outcomes. Thank you.